but I find this technique very useful, especially for social science researcher. And today I'm going to share more detail about why, beside a lot of arguments regarding PLS, and among, like, right now we have a lot of terminologies such as CCA, confirmatory composite analysis, and then when to use CFA, confirmatory factor analysis. But why not look into the most fundamental of research, which is research design? And using this technique itself with the PLS algorithm is somehow relates to design. So today we're going to cover this. And let me introduce myself. My name is Jacky Cheah Junhua. I'm from Universiti Putra, Malaysia, at the School of Business Economics, senior lecturer. So yeah, I've been working there for quite some time. So yeah, a bit about me. I'm born in 1988. Yeah, Hyro will say why you put that thing. Yeah, born in 1988. Sorry if you think I'm too young. And I was previously a senior lecturer in Universiti Technology Malaysia at KL, Asman Hashim International Business School. From there, I started to leave UTM, and I moved to my next university. Again, this is my former university where I get my PhD, Universiti Putra Malaysia. And I currently also have another ties with Griffith University, with my friends, with my colleagues. And then if you look into the most right-hand side on the left-hand top, then you could see consumer behavior, right? My field of study will be consumer behavior. I love to do consumer behavior. In the meantime, I like to explore new stuff in statistics. I'm not a statistician, but I love to understand statistics. So yeah, you can see I have uses a lot of software, different software, and I'm still venturing and learning throughout my process. And in terms of international attachment, as you can see, some from Germany, Australia, Taiwan, and Indonesia. So this is some of my attachment that I have been achieved throughout my journey. And to keep it very short and simple, I'm also currently an editor and review boards for some journals. Some of my journals with my colleagues are Journal of Applied Structural Equation Modeling, Journal of Marketing Advances Practices, and guest editor of several SSCI, or should I say Scopus Journal. Or if you're in Australia, then will be ABDC, or if you're in Europe, then ABS. And editorial review board, Asian Journal of Business Research, from suddenly, yeah, Asian Journal of Business Research is my boss journal, Hiram. And then International Journal of Consumer Study, I work very close with this person called Justin Paul, the editor-in-chief of International Journal of Consumer Study. And if you want to know more details about me, then Google Scholar, you can actually find my Google Scholar, and you will know what research that I'm doing. So that's a bit about me. To keep it short and simple, I do not like to introduce myself that much. So let us start. And today the quote of the day is from Napoleon Hill: "If you cannot do great things, do small things in a great way." And I believe in that because I'm not, when we talk about PLS, I'm not like the best or maybe the top of the top, but I do small things. So yeah, I think somehow we could achieve a great way. So that is something I believe in Napoleon Hill. So to keep the ball rolling, let us start with some fundamental. Was asked to talk a bit some fundamental first before we move very detailed regarding these two algorithms. But again, bear in mind, I will try to start with WPLS, then only once I show you guys on how to perform the WPLS, I will move into PLS-Consistent. But again, let us start with WPLS. Okay, so the fundamental of SEM, it is obviously come from the that guy called Herman Wood. In 1908 and 1992, he have two great students, where one is Carl Gustav Gyroscope and one is Jan Bernard Lohmiller. One looked into the covariance-based SEM, which is the Carl Gyroscope. At that time, he involved in a software called Lisrael. He worked very hard to push Lisrael software until it's today. And right now we have other variation of software in covariance-based SEM such as M+, as well as AMOS, which is quite famous in Malaysia, where we use AMOS a lot because it's a GUI, what we call is graphical user interface, and it is so user-friendly to use. On top of that, we have another school of thought by a Germany guy called Jan Bernard Lohmiller. He also is a student of Herman Wood, and he looked into another type of SEM, which is the very well-known right now, called the PLS. Some people will call it in PLS path modeling. Some people will call it PLS as structural equation modeling. And in this PLS-SEM, we have a lot of variation of software, such as the famous one, which I'm going to show you today, is the SmartPLS software. And then we have Excel stat, as well as like PLS graph. But again, back to the fundamental, we have a lot of software in the market, especially when we are doing our social science research. But again, which technique should we use, whether we are moving to covariance-based SEM as well or PLS-SEM. So because of today, the talk is about more on PLS. Therefore, the PLS here, the purpose of using PLS is more towards if you plan to do some exploratory modeling, maybe explanatory a bit, and more on prediction side, then PLS will be a handy technique with the software itself to run your research. But if you talk about focusing on confirmatory world, where you want to confirm your research, then CB-SEM will be a handy software for you to use. So it depends on the purpose and the goal of a researcher to depends what you guys are doing. But as time progresses and when we move on into the world right now, 2020, we talk about big data, we talk about machine learning, things getting moved beyond just confirmatory, right? We always, in the past, we always depends on theory and then data, we confirm the model. But things move beyond that because things are getting more advanced in terms of data analytics. Therefore, predictions tends to getting more handy. And as you can see, obviously that many papers today published in social science are on more on PLS. So yeah, PLS. Let us start. I hope I explained some fundamental of PLS, like what Dr. Hiram Ting asked me to do so. So yeah, it's about PLS. So today, we know we are talking about PLS, and I hope the user here are, very in favor. Very in favor to PLS SEM. So therefore, we talk about something regarding sampling technique issue. A lot of researcher, social science researcher, always, have a big debate on our data that we collected from the population parameters, and we always harp or depends on survey data when we do our research. And from survey data, most of the time we'll use PLS to solve our model, to get our results, and here you go, right? So it's very simple that today we are going to talk about this WPLS, and this WPLS algorithm, it somehow relates to sampling technique issue. So again, back to the fundamental of survey research, okay? Put aside all the research design. I'm talking about more on the sample representative, okay? I know we have a lot of type of like whether our sample represent towards our population, generalizability, but today the focus here is sample representation, okay? When we talk about this sample representation or sample representativeness, so this is very important in why we do a survey research. So most of the time as a survey researcher, we always gather a representative sample, which is quite expensive. And when we try to strike the balance in terms of sample, we want to try to get as close as our population is. Sometimes we'll use a probability sampling. But then there's a certain situation where we also use non-probability sampling. For example, Suster et al. 2018 clearly stated that in marketing research, especially in especially in advertising, it is so difficult to do a probability sampling. Therefore, some people will look into the purposive sampling. But again, there's an issue in terms of representativeness as well as generalizability. But this issue could be a big issue in PLS, but when people say that I'm going to do a research, use a probability sampling, we just run PLS using the traditional PLS algorithm, like what we always do and what you always learn, somehow you will get a tremendously biased result. It is because of unequal selection probabilities as well as non-response or maybe non-coverage pose of threat to a sample representativeness. So what does this unequal selection probabilities and what is actually called sample representativeness? So let us go a bit more detail. In 2016 itself, Jan Michael Becker and Ida Rosnita Ismail have come out with a technique called W-weighted PLS. This W-weighted PLS tends to be very handy to deal with sample representativeness as well as unequal sample that you collected. For example, this technique WPLS, researcher can assign sampling weight to each observation in order to make the weighted observation represent closely towards the population. But again, what is that itself called sample representativeness? Let me give you an example. For example, if you plan to collect a data, okay, put aside probability and non-probability sampling. Just imagine you are planning to collect a data and you will somehow know the population where you're going to collect your data. You strongly believe that when you go and collect data in the population, you will have, like, for example, more females compared to male. Okay, for example, or maybe in this example here stated very clear that maybe equal in terms of the population, males and female. Like, for example, I plan to collect data in KL. I know that in KL, the population between male and female are equal. But at the end of the day, when you collect data, sometimes it is beyond our control. For example, you will collect back 60 males and 40 females. In such a case, when you collected back 60 males and 40 females, you will not have equal share of males and females according to the population itself. Therefore, Jan Michael Becker created this technique called WPLS, or somehow people could say sampling weights, which could help to, normalize. I use the word normalize, or probably there's a better word. All of a sudden I couldn't think. Maybe help you to balance out the ratio of the data that you have so that it could represent towards the population in terms of representativeness, not generalizability, but I'm using the word representativeness. But again, since this technique, WPLS was, WPLS itself is a technique from PLS, but this weighted sampling, this sampling weights or weighted sampling, this technique has been there in the maybe 80s or 90s, where SPSS itself in the first generation software also can easily perform this weighted PLS, just that we don't really, use it in our research. But again, Jan Michael Becker was very smart using this first generation idea to implement it in PLS, and therefore it called it as WPLS. In this WPLS itself, very trendy technique, but again, in 2016 until today, there's almost like, from Google Scholar, there's almost like maybe 24, maybe less than 30 citation. If you go through Google Scholar, none of them uses this technique. Is it this technique really bad? Or is this technique really difficult to use? And obviously, when I look into this paper several times, I found this technique is very useful. Besides, we always argue on, whether our data use probability or not probability, whether we use CFA and CCA. Why not researcher look into a better post hoc, I use the word, a better post hoc analysis, which could help you give a more robust result in terms of your empirical findings. So therefore, today I will introduce you guys more detail about this WPLS. Okay, so when I go through the many systematic review in PLS, it is clearly that I found that none of the research in empirical research did on this technique called WPLS, which is almost like 4 years from now. There's no research, none, almost like one or two, maybe one or two research uses WPLS empirically. But most of the systematic review mentioned that it is just mentioned as future of study. You can look into WPLS, or maybe a researcher could actually look into another option, which is WPLS. So they don't really shows how to actually perform this WPLS. Because of that, it gave me an initiative to write an article on this WPLS, which I'm going to show you guys later on the article that written by my colleague, where we have Jose Luis Roldán, Enrico Ciavolino, Prof. Ramayah, as well as Hiram Ting. So because of that, why not we write a guideline? And today I'm going to explain more about this guideline, and it could somehow give you another option and alternative for you to use another algorithm to produce a better and robust results. So what is actually WPLS? Okay, again, WPLS uses algorithm produce weighted. Okay, but before we move into weighted, let us go more. Sorry, all of a sudden it jumped. iPhone. See, Hiram, someone waiting in the room, waiting for you to admit it. So you could actually admit, yeah.
No,
Because,
no worries, Jacky.
okay.
Because we make it clear that if it is somewhat identified, we will not allow.
Okay, okay.
Yeah.
So let us start with the algorithm to understand more on this weighted PLS algorithm. Before I really start on this weighted PLS algorithm, let me explain. The purpose of why Jan Michael Becker created this technique is to help you to generate your measurement model, your structural model in PLS, so that it could represent towards your population. Why we want to represent towards our population? Because sometimes when we collected data, we're gonna skew to one side of one categorical type of respondent. For example, male, female, we will collect more female compared to male. So sometimes this thing will occur. Therefore, this WPLS could handle such situation. So I give you a very basic understanding of what is WPLS all about. But in terms of algorithm, we talk about the step one first. Of course, to use WPLS, we run the traditional PLS where we will calculate weighted composite. And this weighted composite is actually based on iterative regression from the standardized indicator data, where it would then produce a latent variable score. This is a very standard process first step itself to produce latent variable score. From this latent variable score itself, WPLS algorithm will treat each observation equally by taking the weighting of vector into account for each calculation of the mean, variance, and covariance of the composite. How does it create this weighting vector? It creates this weighting vector by through population that you know, somehow a rough number, and divide by the sample that you know, which means sample that you have collected, that you know these are your respondent, and you have your population number, roughly that idea, then you will divide and you will get the ratio number. And this ratio number will use as weighting vector. So in such a case, WPLS-SEM algorithm produce weighted means, weighted covariance of indicator variables over several iterations. So as you can see, the formula here will be weighted mean, weighted variance, and weighted covariance will be used for your measurement model as well as structural model. In step 2 itself, when we run the measurement model, we need to know there's mode A and mode B. But using the new weighted value, included the mean, variance, and covariance, PLS itself will change the mode A and mode B, which is your correlation weight as well as your regression weight in PLS when you run your measurement model, into weighted mode A as well as weighted mode B. So it will be add on the additional of the weighting vector, which is weights of mean, variance, and covariance. With this itself, when you move into structural model stage, we will have another type of path coefficient called weighted path coefficient. We look into standardized beta coefficient, BSW. BSW stands for your path coefficient beta value will become weighted score. So with this itself, it seems to be complicated when I talk about this weighted mean, weighted variance, weighted covariance, but I would show you one very practical example later on, and you will find it very easy. But if you are really into statistics and you look into the formula, you will love it because it calculates based on weighted vector on ratio that you have. So I'm gonna explain this weighted vector ratio that you have in a later stage. But then right now, you just need to remember this WPLS algorithm come from the weighted population divided by the sample that you have, and it will become your weighted vector. Weighted vector will calculate weighted mean, weighted variance, weighted covariance, then you will run into the structural model relationship. So from there itself, our paper, later I'm going to show what paper is this. It is published in Total Quality TQMBE, Total Quality Management and Business Excellence. We propose a more detailed guideline compared to Jan Michael Becker work, so that because Jan Michael Becker work, we found it very difficult for readers to read, especially empirical research. Therefore, we come up with a 4 steps guideline to tell you when to use this WPLS procedure. If you just come in, okay, if you just come into this Zoom and you are unclear what is WPLS all about, again, it is help to correct it helps to correct your sampling design. It helps to correct your sampling design when you data collected. I use the word data collected, okay? Why? Because sometimes our data collection that we collect, we have bias or maybe skewed to one side type of respondent compared to the other. So therefore, that is the reason of why today I introduce you guys WPLS. On top of that, because of some time that our data was skewed to one side, when we run structural model, I recall when there's this SASEM conference. When people go to SASEM, go to the conference, people will see, oh, if the result is significant, you explain it is significant. The result it is not significant, you explain why it is not significant. But being a very particular person, a very meticulous person, I always like to look into the standard error. If your data skewed to one side, again, I give you an example. If you plan to collect the data, like for example, KL, and then you know that KL male and female population is almost roughly the same, and then you do a non-probability sampling and you collect more on the female side, for example, and less on the male side. When you run structural model, your t-value will produce a result, but sometimes it will produce very odd result that your t-value will shoot up more than 10. If you see top journals, you don't see really t-value really shoot up more than 10, some even 20, and then you get a p-value significant. And some even you get a very worse in terms of the t-value. All this is because of the standard error. And this standard error comes because of the skew of the design data collected from you guys if you plan to do your data collection. Therefore, that is the purpose of WPLS, where it will help to, not remedies it, but it helps to should I use the word balance? Maybe it balance back, or maybe based on the weighted value or weighted vector, to balance back the ratio data design that you have, so that when you run your measurement and structural model, it will be more accurate. But again, back to this 4-step. The 4-step will be step 1. I'm going to explain to you how to do this WPLS by first choose the right auxiliary variable for sampling weight. For step 2, determine the sampling weight. Step 3, insert the new adjusted weighting variable for each observation, which means each respondent that you collected, if you have 200 respondents, 200 will adjust the weighted value. And then the step 4, of course, is the easiest one, where you run SmartPLS, you just run your measurement model and your structural model. So let us go one by one. So the first step of doing this WPLS, you need to know and choose the right auxiliary variable. Okay, auxiliary variable here will be your weighted variable. Weighted variable, most of the time it comes from your demographic variable. Okay, let me explain why demographic. Again, just now I mentioned, if you plan to collect data, you could somehow know the population. You do not know the population number, but you could somehow know the population of the context that you're doing. So if you somehow know the context that you're doing, most of the time it is based on demographic variables, where you will know, oh, male and female are equal in that population, for example. So when you choose the right auxiliary variable, most of the time it will become your demographic variable. Most of the time it will be demographic variable. So there are several criteria of choosing this right auxiliary variable. The first one is you need to make sure your outcome variable and the potential weight variable are not correlated. If you want to do this WPLS, you first need to make sure that your outcome variables and your weighted variables are not correlated. Why do I say so? For example, if your outcome variable is time spent studying and your weighted PLS, the weighted variables that you're going to use is gender, there's no correlation between these two constructs. So when there's no correlation with these two constructs, you do not need to adjust any weighted value or weighted vector. So you do not need to adjust anything. So therefore, this is the first rule of thumb. Do not need to have, make sure there's no, if there's no correlation, do not do WPLS. So that is one thing. The second rule of thumb here will be, must not be related to respond or non-respond. Your auxiliary variables or weighted variables should not related to respond and non-respond. For example, if you plan to do a data collection online survey, and you plan to use auxiliary variables, or these called weighted variables, such as age, then it does not make sense for you to do WPLS, because it relates to respond or non-respond respond or non-respond issue. Why it relates? Because for example, when you do an online survey and you base on age as your auxiliary variable, you use age. Try to imagine age, we have like older generation and younger generation. So for online survey, younger generation will always respond faster compared to the older generation. Therefore, in such a case, you have respond and non-respond issue. So in such a case, you cannot do auxiliary variables, use this as sampling weight. You cannot. So this is the second rule of thumb. The third rule of thumb, this is more on the knowledge that a social science researcher must have, especially when they define the population. If you talk about using WPLS to adjust the ratio, again, I use the word to adjust the ratio because, you know, as I give you an example just now, male and female in the population is equal, but you collect one data more on particular female compared to male, then you have bias. So in such a case, if you use a definition like gender, male and female, it is very clear cut for you to use these auxiliary variables or weighted variables. But if you use more at once, like if you plan to do operation management or maybe performance of SME, for example, and you use a definition like manufacturing sector in SME, Malaysia, the definition. If I recall, the definition for manufacturing sector in SME, Malaysia, will be sales turnover not exceeding 50 million and number of full-time employee not exceeding 200. But if you use this definition from this manufacturing SME to different SME sector, then the definition of the way of the population will not be precise. When it is not going to be precise, you will then face difficulty in calculating the ratio weight, because we're going to calculate ratio weight manually so that we can insert this ratio weight into your data set, and from your data set, it will then run into PLS. So we need to have the right definition if you plan to use auxiliary variables, which is difficult to define. So you need to take note on that. The fourth that you need to know that if your auxiliary variable should not use as endogenous, which means if you plan to use your auxiliary variables like doing somehow performing logistic regression, then you cannot do it in you cannot do this WPLS. And the fourth thing about, the fifth thing about this WPLS is you cannot use it for fishing expedition of p hacking. Because why am I going to explain this? When you talk about this fishing expedition and p hacking, I believe that most social science researchers like to do so. Why? Because we want to get everything to be significant. By the way, using WPLS, you will see how it will influence your structural model results, which I'm going to explain in a short while with an example. And then the last but not least is make sure the values of sampling weight are the same. When you produce this, when you calculate this weighted ratio based on the population and sample, we will produce this sampling weight itself. If you get every group and cluster have equal value of sampling weight, then you do not need to do WPLS, which I'm going to explain in a short while. Okay, so I hope you understand this 6th rule of thumb, so that let us proceed. The other rule of thumb is regarding sample size. When you do this W-weighted PLS, the first criteria you need to do is you need to learn the basic fundamental of frequency test or maybe cross-tab table that you can easily perform in your SPSS or maybe Stata or maybe Excel software. But when you do these frequency tests and cross-tab tables, you need to make sure that when you want to check on the data that you collected, whether it falls according to the population, each cluster, each group itself must have a minimum requirement sample size of maybe 10 observation within cell sample, or larger or maybe equal to 20 according to Westphal as well as Kelton itself 1983. Okay, so I hope you know the sample size. I will go through the details with example. For example, if I plan to, okay, if for example I planning, this is an example from the paper that we published together, and for example, there's a imbalance in terms of data I collected based on age and gender. So I'm going to use age multiply with gender based on the sample that I have as well as the population that I know. From there, I do simply a cross tabulation, which is easy to check on my sample size that I have collected. So from here itself, we break into male, female based on different age. And you can see very clearly based on this cross tab result, gender and age, And you can see the result. The weird part will be at the age of 45 to 54, with the gender male and female, when I do a cross tab, the within cell, one have 2 sample size and the other will have 7, or a total of 9. And this itself cannot be used when you do WPLS. Why? Either you can delete this particular group of people, or you need to find a way to solve this 45 to 54 age, included male and female. So this is just an example that I'll tell you why sample size is important. When you do a cross tab, you will see within cell whether achieve more than 10 sample size or not. So this is a criteria regarding sample size. It is not the PLS sample size. It is a weighted PLS sample size criteria. So once you get this, the step 2 is you need to start calculating the sampling weights. You remember I mentioned that when to calculate the weighting vector or weighting value itself, you need to use the population divided by sample. How does it calculate? Most of the time when we do a sampling, when we go and do data collection, we will somehow know the population number. Of course, we will not get the sampling frame. Just put aside, right now I'm not talking about probability sampling, I'm not talking about non-probability sampling, I'm talking about we will somehow get to know the rough number of the population. From the rough number of population, for example, let's say age gender, 15 to 24 years old with a male, the population in KL is 27,34859. For example, this is an example. So from here, we will then need to calculate the proportion of the population. And the proportion of population is calculated based on population divided by the total of population. You will get the proportion of population. From there, we're going to have our sample that we collected. In the sample that we collected, we also use the same technique where sample divided by the total of sample, you will get proportion of the sample. From there itself, you will use proportion of population divided by proportion of sample, you will then get the weighted value. And this weighted value is called observation sampling weight, or some people call it as weighted vector, to be corrected in terms of your mean, in terms of your weighted mean, weighted covariance, and weighted variance. So I'm going to show you how to calculate this step, but now I just explained this is the step 2. Step 1 is you need to make sure you fulfill the 6 rule of thumb plus the sample size of within the cluster. From there itself, let's say just now there's one cluster itself have the total of 9 sample. I deleted the sample. So right now, when you move into step 2, you can see that there is only 3 type of age and 2 type of gender. So from there, we will then calculate this proportion of population as well as proportion of sample. So from here itself, let us move on. We will move into the third step. In third step, once we have calculated each of the cluster have the weight value of, for example, 1.666, 0.542, 1.547, 0.631, 2.277, and 1.530, we're going to use this adjusted weighted value or weighted variables to insert in each observation data that you collected. For example, to insert on each respondent itself, so that it could adjust the value when you insert it in PLS. So we can do this easily by using Excel spreadsheet or maybe SPSS software. But today I'm going to show you how to use this in SPSS. It is all about syntax. I will give you the syntax later so that you can actually perform it your own time. Okay, you can perform it on your own time. And in the last step 4, once you adjusted, you can include this weighting variable in your software, so it will run the analysis of your measurement and structural model so that it can perform fantastically, and you will adjust the value of your measurement as well as your structural model. Okay, I hope you understand this 4 step. I try to make it very simple. You know why I try my best to make it simple, but let me explain. There's a reason why Jan Michael Becker and Ida Ismail, the paper 2016, not getting citation is because the paper tends to be quite confusing with a lot of fancy statistics. So therefore, we have a paper that provides guidelines, but I don't know, for me, I think the guidelines sound simple, but I hope that this guideline will also help you guys to understand better about this WPLS. Okay, so in my guideline of this paper, which was published, I uses a model from another paper, International Journal of Contemporary Hospitality Management. This is a model that we have published before. So, example, we have service quality, service equity, confidence benefit, perceived sacrifice, customer satisfaction, and repurchase intention. So this is an empirical illustration. We have checked the measurement model. The results are all the same. Nothing changes between WPLS algorithm and normal PLS algorithm. But what I want to highlight to you, why it is important to look into WPLS is it helps you to adjust your value in terms of the path coefficient as well as standard error, so that it will produce the best result in terms of your t-value as well as your conclusion towards your discussion. As you can see in the result, based on that model just now, put aside all the relationship lead to customer satisfaction, because the result is roughly the same. But try look into the confidence benefit to RI. RI mean repurchase intention. And then try look into perceived sacrifice to repurchase intention, service equity to repurchase intention, service quality to repurchase intention. Last but not least is customer satisfaction towards repurchase intention. As you can see in the results, that it is clearly stated that if you use PLS-SEM algorithm to run the traditional PLS without adjusting the weighted value based on the population and sample of the ratio, the result clearly shows that there are three results significant. Okay, one is will be confident benefit to RI. The other one will be service equity to RI. Third one will be service quality to RI. CS to RI. So there's a three significant from the relationship. With this itself, if you are a researcher, you will say, hooray, right? You will say, hooray, I got a lot of significant, right? But if you really adjust the WPLS because of your data skew to one side, based on the, the table cross step that I showed just now, you can see that when I insert this weighted value and run this WPLS, only one result significant, which is CS to RI. Only one result significant. And the rest of the relationship to RI, it is not significant. In such a case, there's a bias if you don't adjust to it. Why there's a bias? If you look into the R square, the result will be different. Like for example, in CS, the R square will be higher in this WPLS, but in terms of repurchase intention, it is lower in WPLS compared to the PLS. But let us look into the Q square. Q square itself do not have much different. It is somehow look alike in R square, but from here itself, we can clearly see that when we adjust the WPLS algorithm, it gives you more representative of your structural model results towards your population. I'm not saying generalizability, I'm saying representativeness. So beside this, let us look into the mediation analysis. In terms of mediation analysis, it is very obvious that if you don't adjust this WPLS, then if you just look into PLS, I use the so-called Zhao et al. In terms of the partial and full mediation. So if you look into the type of mediation, Zhao et al., if I use the normal traditional PLS algorithm, it shows that 2 partial mediation, 2 full mediation. But if I use WPLS, it clearly shows that 4 mediators itself is full mediation. So therefore, adjust or not to adjust WPLS, it's something to ponder from you guys, okay? So you need to think whether you need to adjust or not, based on the step 1, the criteria that I have explained, as well, whether you really want to adjust or not. Because I often see a lot of researchers, when they move into structural model, when they explain and they interpret, of course, many of the paper published, for me, so what, right? If you, you publish, you discuss, but how sure you are your sample is representative? You can get all the result that you want, but if your sample is not representativeness enough, then there's a doubt in terms of replicability as well as other issue. So therefore, there's something to ponder. Just now, I just mentioned Q square, but what about another type of prediction, which is the PLS Predict, which is quite famous today. So I'm going to explain a bit about this thing. If I look into the assessment of this prediction in terms more advanced, such as PLS Predict and the model selection criteria, which is this one, which look into the AIC and BIC, but because there's a simulation study done by Sharma et al. 2019 A and B, they has mentioned that using BIC and GM is the best for model comparison. Therefore, looking to this article, as you can see, so we also run a quick analysis on using just BIC as well as PLS Predict. In such a case, one of the reasons why most of the time your prediction fail is because your sample is not representative enough. Remember, I'm saying sample representative, not generalizability. So when we talk about this sample representativeness, when I just run on the traditional PLS algorithm, the traditional PLS algorithm, I think there's a mistake in my table, but let me explain in detail. As you can see on the rate value, your left-hand side will be your traditional PLS, and sorry. What I mean here is like red hand, you see the rate value. Rate value means the best number, the best value, okay? And then we have WPLS compared with PLS. When we look into the customer satisfaction as the first endogenous or the mediator, we clearly shows that WPLS tends to have better prediction in terms of out of sample prediction, which is using the PLS Predict criteria, where we have RMSE, MAE, and Q-square predict. And compared with the model selection criteria, we just use DIC. Customer satisfaction for WPLS-SEM algorithm is way better than PLS. But when we look into repurchase intention, it clearly also shows that in terms of PLS predict value, the WPLS-SEM tends to work better. But in terms of the DIC criteria, it tends to be the PLS, the traditional criteria works better. But overall, it could somehow tell you that the WPLS technique, which is adjust your population and your sample so that you get the right weighting value or weighting to adjust your vector of your analysis, will produce a better in terms of your structural model as well as prediction. So this is something to explain, to summarize everything. To use WPLS or not to use PLS, I mean, to use WPLS SEM or not to use, it depends on you. But then again, we are talking about sample representativeness. And this is the biggest issue that I don't see many people tackle in terms of their publication. But again, there's no, based on my summary, there's no disclosed any differences in terms of the measurement model evaluation. It is same like Beckel and Ismail 2016. But in terms of structural model, there's a substantial difference in terms of the results of structural model estimation. And in such a case, we could see in terms of their path coefficient, their R square, their Q square, their in-sample criteria like BIC, as well as the out-of-sample prediction using PLS Predict. So therefore, this is something for you to ponder, whether to use WPLS or not. And then we also found that in terms of mediation, it could distort the explanation, whether full or partial. But again, I'm not planning to discuss any full and partial here. There's always two schools of thought. If you talk about the European school, they still harp on the full and partial. But if you talk about the US school of thought, they just say mediation. But again, what I want to highlight here is the result will be different, okay? And then therefore, there's always a consequences for you to use WPLS. Why? The consequences here will be, it will give you different explanation in terms of discussion, theoretical, and managerial implication. If you do it right, especially when you're trying to your best to get a sample representative and you can't get it, and then the only way for you to adjust is using this WPLS. And WPLS is a post hoc test so that you can adjust and you will produce a better structural model result. Again, you can't use this for p-hacking or maybe trying to get as much p-value you want to get significant. You can't do that. But the purpose here is try to get your structural result to be representativeness, to get representativeness. Okay, so that's all about this technique. I'm going to stop here before I will go to the question. I'm going to stop here before I show you how to perform these steps. Okay, so let me stop here. I will see if there's any question. But